So, finally ready. I'm Eilish.
And I'm Killashandra.
And we are 2/3 of the group that worked on CMS triggers. Connor couldn't be here today, so we're doing his part. So, an overview of the CMS detector to remind you of the previous CMS talk that we had. It's at the LHC. It's what's called a general purpose detector, where it's not like specifically optimized for any one thing. It's just like, let's see what we find. And since it has to deal with so many collisions per second, you can't possibly save all of them. So it uses an automated trigger system to decide which events are interesting and which it can just forget. And so at the 8 TeV energy that I was working at before, it had a certain set of triggers that just automatically weeded through all of the data and said, these events are interesting. Now that it's upgrading to a higher energy, it will probably need a new set of triggers, since there will be new kinds of events and collisions that we may want to look at. So that's essentially what we've been working on, is like looking at some of those triggers around the top quark.
In order to do this, we're looking at top quark K from simulated events, and Connor took the muons to look at them, at how their energies are. I looked at electrons, and Eilish looked at jets. We wrote programs in Root to create histograms and graphs to present this data, which is next. This is the muons from the TT bar 8 TeV and 13 TeV. Sorry, yeah. Really, the cuts seem pretty the same. Both of them have the same cuts. The colored graph shows it using two different electrons, a leading electron and following electron, showing different cuts for the energies. The first one just shows muons, and the first one shows just one muon and if it meets the cut or not, with different percentages of how many met the cut. This is the same thing except with electrons, still in TT bar.
And then I did it a bit differently, because 2 years ago during QuarkNet, I was making histograms of other data, and so I already had some of the code to make histograms like this, where you have the two different histograms overlaid on the same plot. And so I figured as a good starting point, I could see if I could just access the trees and put them together. And I ended up getting this done yesterday morning. And so I'd like to improve it, but it's what I was able to get in time for the presentation, so it's what I have. It's pretty much a set of cuts that was in a paper that Professor Beringer directed me to around cutting jet energies and the angles and the detectors. And so there's this histogram, and then there's another one on the next slide, and it's the same events, it's just these are been based upon the angle they were in the detector, and the other one is been based upon the momentum that it has. And so I pulled them from the two different root trees where they were stored and applied the cuts, and this is what I got for the eta. And then this is the exact same thing with the exact same events, just then for the momentum, and the cut is at 40 like it was in the paper, so that's why there's the really sharp line there. And then future work.
We're going to try to improve the histograms and try to get the different TeVs on the same histogram, and try to find newer cuts that would work when we upgrade to 13 TeV.
And I'm going to try to convert the histograms I have to more like a scatter plot, so we can look at both of them at the same time and have a better idea of what's actually going on than just two separate histograms that are related, but it doesn't have quite as much information readily available. So hopefully I'll be able to continue working on that in the next couple of days. And then what would also be handy is to figure out the percentage of events that survive the cuts. since that's really what we're concerned about, is like what we're actually able to see with these triggers, and trying to like get as much information as we can without using too much data, since there's only so many events to go around. And we're gonna look at different cuts for the data. Any questions? Yeah.
A question. So the LHC ran at 8 TeV, right? And it's about to run at 13. Is that right?
I think they were hoping to get it up to 14 TeV, but the simulated data we have is at 13, and so.
So you have simulated data, and then the 8 is the 8 TeV actual data.
It's also simulated.
It's also simulated. Okay.
Yes.
There are these cuts that you tweaked. What does it mean for the cuts to work? What was the goal?
The way that Professor Beringer explained it to us whenever we were meeting is that each experiment is budgeted a certain number of cuts, so that you can, like the Higgs boson will get to look at more events, and the top quark people get to look at fewer events. And so you want to get as many interesting events as you can. And so what the cuts are trying to accomplish is get rid of anything that is not like interesting at all, and only focus in on the most interesting events.
Yeah, you have limited bandwidth for being able to write stuff out, and so you can only get budgeted so much bandwidth.
Are these hardware things that will be programmed in?
Yeah.
Oh.
Yeah. Well, there's a hardware bit, and then there's a software bit. Probably most of this will happen in the software.
Yeah, these are the high-level triggers. So they have hardware that just does really simple ones, and that can get, I think, like tens of thousands, maybe 100,000 events per second. But the software has got it down to like 300 or 400 events a second. So, Eilish, which one were you looking at?
T channel. I was looking at T
okay.
channel.
Okay.
All right. There's no more questions. Thank you.